You see, we saw earlier in EIGRP we have a dual algorithm. I told
Right.
you this is the one which prevents the loop.
Loop. Yes.
Now we are going to focus more on this in our class today. And also
Okay.
we will discuss about a few more things before we get into that. Number one,
Okay.
how the neighbor discovery happens. See, in RIP there is no neighbor discovery. RIP routing protocol never discovers neighbor. There is no neighbor discovery in RIP. But all other protocol needs neighbor to be discovered, either to be discovered or to be configured. You can also statically configure neighbors. In OSPF, we used to do sometime. In RIP, you may do it if you want, but we mostly don't do it in RIP and EIGRP. Neighbors are dynamically discovered using hello packets. If you take BGP, we don't send any hello packet in BGP. So neighbor needs to be manually configured. So using the hello packets, one router will expose itself to the other router. Another router will learn this router as a neighbor. So every router they share the hello packets, and it's the hello packet that is going to help to discover neighbor. Not only that, when the hello packet stops coming, then the router understands that the neighbor is dead. And if a hello packet comes again, router recovers the neighbor. So it is the same hello packet which is used for both discovery and recovery of neighbor. Now RTP is a protocol which is going to guarantee the delivery of all BGP update, EIGRP update packets, all packets to its neighbor. RTP stands for Reliable Transport Protocol. In EIGRP, we don't have real-time protocol. That is also RTP, but the real-time protocol comes in voice. That's not EIGRP. Real-time protocol is not EIGRP. Reliable Transport Protocol is EIGRP. RTP, Reliable Transport Protocol. Reliable Transport Protocol, what is the use of this protocol? Why do we need this? The reason why we need this is we don't have any connection-oriented approach in EIGRP. If you take a BGP uses TCP. TCP is connection-oriented. So there is an acknowledgement that will guarantee the delivery. The acknowledgement guarantees the delivery of packets. Whereas in Reliable Transport Protocol, RTP, there should be something giving guarantee. That is this RTP, Reliable Transport Protocol. In EIGRP, RTP is the mechanism using which EIGRP will know that we are connected. We have given some update and update has come. Means update has reached the neighbor. So need not do too much research on this RTP because it's not so important. This is not an industry standard protocol. EIGRP uses this particular algorithm to guarantee. Because EIGRP, they don't use TCP or UDP. They use IP. EIGRP works on IP layer, network layer, not transport layer. EAGRP is not working on application layer. EAGRP is simply working on network layer. So network layer protocols, there is no guaranteed acknowledgement. Guarantee. There is no acknowledgement. So to provide acknowledgement, EAGRP has got additional protocol called Reliable Transfer Protocol. Do you have any question on RTP?
No, I don't have any question.
Thank you. Next is the dual diffusing update algorithm. Now about this, we are going to see more in this session. But what it does is, this is the one which is taking responsibility of picking the low cost path. You may have multiple paths to destination. But among multiple paths, a low cost path need to be elected. Low cost path, cheap cost path, low cost path. Every routing protocol uses some metric. That metric is helping the protocol to understand whether this is low cost or costly or high cost. Every protocol always deserve to have a low cost. That is how they are designed. The low cost path is what considered to be the best path. Even in RIP we saw no less number of hops. That's a low cost. In EIGRP, it is the dual algorithm which is picking the path with a low cost. Not only that, the loop free. The path that it is going to pick also need to be a loop free path. For every destination, routing protocol have to recommend a path which is low cost as well as a loop free path. Very important. Next, EIGRP is a protocol dependent module. Earlier I was telling you, for every single layer 3 protocol, there is a separate module of EIGRP. So if in case you are using Apple Talk as a layer 3 protocol, your way of configuring EIGRP will be different from what we are doing in this course. The commands will be different. The algorithm is going to be different. So EIGRP is independent of modules. IP module you cannot use in Apple Talk. Apple Talk module you cannot use in IP. So every protocol has its own EIGRP module. IP has got its own, Novel Network has its own, Apple Talk has its own. They work independently. Yeah. Any question on these points?
No, I'm good.
Now, EIGRP also maintains neighbor like OSPF and ISIS and BGP. EIGRP also maintains neighbor. Using hello packets, they discover neighbor and the learned neighbor and the interface via which the neighbor is learned will be maintained in a table, which is what called as neighbor table. EIGRP maintains neighbor table. For every neighbor, The interface via which the neighbor is connected is also listed in the neighbor table. So neighbor table will have the next hop router's address as well as the interface. Now, before we go to this topology table, we have something big to learn. But for time being, I just want to skip this and come to the third table. Then I'll go back. You know about the third table. See here, the third table is routing table. I've skipped the topology table.
Okay.
I've skipped the topology table.
Okay.
Let's finish routing table and go back.
Okay.
What will the routing table have? Routing table will have the best routes alone for every destination. Yeah, only the best route. Whereas the topology table which we are going to see now, it will have both best route as well as the alternate routes. That's why here it is lists. It says lists of all routes learned from EIGRP neighbor. All routes, not only the best routes. The best route are seen in the topology table. Routing table. The best route is seen in routing table. The only best route is seen in the routing table. Routing table will not have all possible routes, all available routes. Routing table will only have the best routes. Whereas topology table will have the best and also the alternate. If the alternate satisfies the dual algorithms condition. I spoke about this in the previous class. I'm going to repeat that in depth today. I said loop is prevented because there is a condition. Loop is prevented because there is a condition in picking up the backup path. Underline the word. There is a condition in picking up the backup path. Not every available path can become a backup path. See, after electing the primary path, dual algorithm will elect a backup path. But it won't simply elect some path. It will check for a few conditions. The reason why those conditions are there in order to prevent loop. Because dual algorithm not only picks the low cost path, it is also responsible to avoid loop. So to prevent loop, it won't simply elect the alternate paths. It will check for a few things as a condition. If that condition is met, then it accepts that as a best alternate path. And that alternate path will be placed into the topology table. The alternate path will not go to the routing table. It stays in the topology table. Now I want to ask you a question. Will there be best?
Okay, go ahead.
Will there be best route and alternate route in topology table? What is your answer? Will there be both best and alternate routes to destination, or we will see only the alternate routes in the topology table?
I think both will be in there. Like I said, list of all routes
Very
learned.
nice. Well said. You're right. In the topology table, you will have both best and the alternate paths that satisfies the condition will be listed in the topology table. What is that condition called as? The condition is called as feasibility condition. Feasibility condition. Feasible condition. We'll see what it is. So now, having this introduction to the topology table, I would like to go back to the previous page. This one we just saw. List all the routes learned from the EIGRP neighbor. You will see in the topology table, but I want to make a correction. It is not going to be all learned routes. It is going to be the best route and the routes that fulfilled the condition, that satisfied the feasibility condition. The list of all routes mean here, it is not meaning that all 100 routes to the destination. No. You may have 100 routes, but the feasibility condition might have been satisfied by maybe 4 routes or 3 routes out of 100. If all routes are learned and maintained in topology table, one topology table cannot contain in a large network. Topology cannot hold it. Second one, CPU utilization. Third one, loop is very likely. Loop is very easy. You have all routes. You have all routes. Then there are chances of looping. When you have all routes available in the topology table, confusion. So picking up the alternate path is only through dual algorithm. Picking up the best route is also through dual algorithm. So picking up alternate path is what we are going to focus now. Very important now. We are going to see how the backup path, the alternate path is elected.
Okay.
I was naming a condition. What is the condition name?
Feasibility condition.
Yes. Now, why it is named as feasibility condition? See, the best route has got a name called successor route. The name for the best route is successor route. Where do we see the successor route? Can you answer? Where all I can see successor route?
You can see it in the routing table because that's the best one.
Yep. You will see the successor route in routing table as well as the topology table. Yes. Now, I was trying to answer this question. Why the condition is called feasible condition? Because the backup path, it is called as feasible successor. Feasible successor means it is not best path.
Okay.
Feasible successor is not a successor. Feasible successor is a backup path. Feasible successor is a backup path. Feasible successor is a backup path. Successor is a primary path. Feasible successor is a backup path. Topology table needs to now find out the feasible successor. So it uses feasibility condition. Now let us go back to one page back. You see, when we finish learning this page, you will know what it is. Feasibility condition mean. First point, dual algorithm terminologies. Dual algorithm selects low cost, loop free path to each destination. Second point, the advertised distance is nothing but the cost between the next router to the final destination. You understand? What is advertised distance? The advertised distance is the metric what my neighbor gives to me. My neighbor says to go to airport 10 kilometers. I repeat, My neighbor is telling, hey, Robert, for you, I don't know, but for me, 10 kilometers for me to reach airport. Now what Robert does, okay, if for Jay it is 10 kilometer, for me it should be 20 because me and Jay is 10 kilometer away. So if I go through Jay, it is 20 kilometer. Robert says, I know it's 20 kilometer because for Jay it is 10 kilometer, who is closer to the airport. And I am 10 kilometer away from Jay. So for me, Robert, the total distance is 20 kilometers. So based on the advertisement that came from Jay, Robert managed to calculate his metric via J. That is what called as feasible distance. See, feasible successor is different, feasible distance is different. Feasible distance is nothing but the total distance. Now, we may have multiple paths. Each path's total distance will be different. The low cost total distance is what called as lowest feasible distance. I want to ask you a question. Shall I?
Yes, go ahead.
When you got multiple paths, each path is going to have one FD, isn't it? One feasible distance. Correct.
Right.
Now, the lowest FD is what considered as the lowest cost, isn't it?
Yes.
Now, will successor have the lowest FD or feasible successor will have lowest FD? Who will have the lowest FD?
Successor.
Very well said. So, the lowest FD is what called as lowest cost. Successor is the one which is having the low cost path. Now, coming to the last point, did you understand the first 5 points?
Yes, sir.
Now, coming to the last point. In order to select a feasible successor, what is feasible successor? Alternate route, backup route. In order to elect the alternate route feasible successor, this is the condition. See the bracket. The advertised distance of the backup route, I'm just using the word backup route instead of feasible successor. The advertised distance of the backup route must be less than the FD of the successor. You understood this point?
Yes, it says.
But I want to explain you with a diagram.
Okay.
So that you will have more clarity on what I am talking.
Okay.
I'm connecting my pen and the pad. Here we go. You see, R1 connects to R2 and reaches this destination 2222 via A and B. So you got two paths, right? Now, for this 1.1.1.1, are we connected or you lost it? Are you there? Okay,
I'm still
great,
here.
great.
Just on
Thank you.
mute.
Thank you. So in order to go to 2222, you got two paths. And let's say the metric here for R2 to reach 2222 is 10. And for A, R2 is saying, hey, 10 is the metric to 2222. That is what called as advertised distance. R2 is advertising 10. And A says, okay, then for me it is 20. Why? Because here it is 10. So this is for A, what is the FD now? For A, FD is 20. Now, A is advertising 20. That is what AD for whom? R1. You understand what is AD? Advertised distance. Router 2 is saying, hey, for me it is 20. Then R1 says, okay, between you and me, I got 10. So my metric is
30.
30. 30 is the FD via router A. Do you understand that?
Yes.
Now let us go to the down one. Again, here also it says, hey, 10 is the advertised distance. And here is 8. Router 3 says, sorry, router B says, for me it is 18. FD is 18.
18.
FD is 18. And that is what the AD to R1. R1 receives 18 for R1, that is called AD, isn't it? AD. AD says 18. And router 1 says, okay, for me it is 10. So for me and you it is 10, then 18 plus 10 is 28.
28.
So FD via B is 28. Now which one is the successor path? Via B. Agreed?
Via B.
Okay.
Yes.
Now this path is already elected. Now if this is the successor path, what is the successor FD value? 28.
28.
28. Now you see, to elect a feasible successor, AD of the feasible successor, which is a feasible successor? Path via A. Agree?
Right. Right.
Now, what is the AD coming from A?
20.
20 must be less than the FD of the current
28.
successor. Is it true or false? Yes, it is true.
True.
Now, EHRP will say you may use this as a backup path. If this condition is met, there will not be a loop. If loop is there, definitely it will keep on growing. It won't be 20, it will be 30, 38, 48. It will keep on growing because there's a loop.
Right.
When the alternate path AD is less than the successor FD, then that can be considered as a feasible successor. This is what called as feasibility condition. You understood?
Yes.
Now, this is the main story of this chapter. I will stop.